Thank you very much. Well, ladies and gentlemen, welcome to this micro-seminar with the School of Engineering, and I'm Mike Gruntman. I will tell you a few words about myself in a second. So, but first of all, you are in the facilities of the so-called distance education network, because half of you participants who enrolled in this seminar are outside of engineering. Our engineering students would learn later about this, but for you from other departments across the campus. So we'll be talking about this more tomorrow. Continuing education is the way of life for engineers in many industries. And industry very often hires Bachelor of Science students and Bachelor of Science graduates, and then they actually pay tuition for them to go to school to get Master of Science degrees. So, and many of them take courses through distance education, and the USC is very big on that. We're one of the largest distance education programs in engineering. So the same classes that are being taught to students, as you are coming to such a classroom, the same classes are webcast and captured also and go to the server for remote students to study either in real time or later. So it's a big deal. Therefore, these facilities are very different from other classrooms that you will be exposed in your studies in the undergraduate years, although some senior classes are also webcast. So we're at this wonderful facility. And after this brief introduction, so let me ask our operator to switch to my laptop now. And so our seminar is two parts. One is today, one is tomorrow, from Firecrackers to Interstellar Flight. So today we will concentrate on the first 1,000 years, on the historical parts. And again, I encourage everybody to pick up for the handouts, and some other stuff is there. Giveaways. So today we'll be talking about history, how we got to this situation, and we broke into space. And tomorrow we'll talk about space in the 21st century. So what people do in space, what are the main motivations, what are the focus of activities, and particularly tomorrow we'll talk about the scope of the worldwide space enterprise. So we will see just how many people and how much money is involved in that. If you have any questions during the presentation, don't hesitate, just interrupt and ask the question. So, a few words about myself. I am professor of astronautics, and at USC we have a very special situation compared to other universities, because almost everywhere space and aeronautics, airplanes, are combined in aerospace departments. We are unique. So I'm professor of astronautics, and actually I was the founding chairman of the department, and now I am again, unfortunately, the chairman of the department. It's a lot of administrative work, so it's not that much fun. As a student, you don't see a lot of stuff that we have to do, but trust me, it's a lot of uninteresting things that we have to do in order to make your life comfortable and our classes effective, and the process producing the desired results. So I'm a specialist in space technology, in space science, also in rocketry, also in space history and space education. And actually this first part that we will be talking about today, this first part is based in part on a book that I published more than 10 years ago that's shown on the left. So we're at the times when actually this year there are a number of 60th anniversaries, and obviously they're very related to space. And actually the most important would be in early October, when the first artificial satellite of the Earth was launched, Sputnik. So what happened after the first launches is very well known, particularly the Apollo program landing on the moon and the space shuttle, and many of you were just following that in the media. But how we got to this point of the breaking into space, and who were these individuals that blazed the trail to achievements in rocketry and space technology. This is actually not that well known, and I hope that you will find it interesting to see how many countries and how many people contributed many years ago to various steps in the technology that enabled space exploration today, and also multiple space applications that we have today. And as I said, we are at the time of the 60th anniversaries. Now, actually in 4 days, in 5 days, there will be an anniversary of the 60th anniversary of the first intercontinental ballistic missile demonstrated. And when you demonstrate such a missile, after that, it's almost piece of cake to put a satellite in the orbit. You just slightly, your engines are powerful enough, your technology is mature, you just slightly modify the technology and you could put a satellite into orbit. Conversely, if you put a satellite in orbit, as North Korea did 4 or 5 years ago, that means that they can build an ICBM, the Intercontinental Ballistic Missile. So it's technologies are there. So if we go 2,000 years back in time, so it was ancient Greece and ancient Greeks scattered on the Mediterranean who first observed the principle of rocket propulsion. Basically, you expel mass in one direction and it creates a force in the opposite direction, thrust. And the first actually such device was built called Aeolipile. It was built in the early first century of our time, common era. So the Greeks observed this, but they were not very practical people, so they never put into applications these kind of devices. So in the first rockets really appeared in China, and it was about 1,000 years ago. They were solid rockets, so we will distinguish always between solid rockets and liquids, and this refers to the state of the propellant. The propellants are in liquid form that are combust and burn in the rockets. It's liquid propulsion systems. If it's solid, then it's solid rockets. So Chinese rockets were rather primitive. So let me start my pointer. So rather primitive, they were basically a stick with attached a small rocket device on top. And these devices propagated in arrows, as you can think about that. When exactly it happened, very difficult to say. And the problem is that in the Chinese language, the rocket literally is rendered, the word rocket, as a fire arrow. In the beginning, the warriors shot arrows with inflammable substances on that. So they were called fire arrows. At a certain moment of time, they replayed this incendiary substance on the tips of the arrows with the devices that were really rockets that produces force, thrust. But the word in the documents, the same, was used to describe them. So if you study ancient documents, you can't really tell when exactly they became real rockets rather than incendiary arrows. Again, fire arrows is a literal translation from Chinese. So, but it is known that gunpowder appeared in China around the year 1045, and the first really rockets were used in 1232, although maybe even earlier, but again, we just don't know that. The first Chinese rockets were very primitive, as just shown here. They flew only a couple hundred yards. They were relatively small, but what Chinese excelled in building multiple launchers. If I use today's terminology, it was basically rocket baskets. So there was a few dozens of rockets, and 1 or 2 soldiers could carry them and operate them in like salvos. So this would be in contrast to ancient India, where much bigger rockets were developed, and I will talk about this in a second. So, and we really don't know exactly whether it's India or China were the first to develop the first rockets, but Chinese records are much earlier. So it's therefore usually people say that China was the first to start rocketry. So the earliest form of propellant that is being used was gunpowder, although the word is a misnomer because guns appeared much later, only in the 14th century, and the rockets were already in the 12th or 13th century. But this black powder or gunpowder consisted of charcoal, sulfur, and saltpeter. And these things were known from the times immemorial. And charcoal and sulfur, they are available all over the world. However, saltpeter is easily obtainable. It's in many places on the surface, in China and India. In Europe, there's only one place, I think, in Sicily or somewhere there, where you have this openly available saltpeter. So availability of saltpeter was the key for emergence of gunpowder or black powder. And therefore, in India and China, because it was easily available in contrast to other areas in the world, so these were the places where the gunpowder appeared, and then applications in rocketry started. So Chinese developed these first early rockets, as we mentioned, and then it started the first wave of the missile proliferation. You can think about that. So the Mongols took over the Chinese empire, and they absorbed Chinese technology. And then Mongolian troops carried this technology across the world. So they landed and brought rocketry to Japan in the 13th century, to Java, to Korea. There are some historical records. People claim that Mongolian troops bombarded Baghdad in 1258 using rockets, but most likely these were not rockets, but simply inflammable things. It's a lot of linguistical issues here, just to how you interpret the records. It's not clear where the Chinese brought rocketry to India, or development was indigenous there. And certainly rockets were brought by Mongolian troops to Europe. They used it first time in Legnica in 1241. However, so people very often say that Mongols learned from Chinese and then the Europeans learned from Mongols rocketry. This may not necessarily be the case, because there was a lot of indigenous development in Europe as well. For example, in the Byzantine Empire, there was the developed Greek fire, and it was the 6th or 7th century, actually, much earlier than the gunpowder was developed in China. And there was a fellow, Marcus Gracchus, it's a Greek fellow, who described the gunpowder like mixtures and a lot of incendiary things as early as 9th century. So it's very hard to tell, because again, the smart people are everywhere, and we, particularly in engineering, we should just remember that whatever we develop, say here in the United States, other countries may develop on their own. There are smart people everywhere in every part of the world. In any case, in Europe, there was an interest increase in the things firing and burning in the 13th century. Say in Paris and France, there was a special research institution even established for research in saltpeter, which basically in gunpowder. Then European, actually crusaders in 1249 met some rocket-propelled devices used against them when they were in the Middle East. But this was the time when Italian cities, very powerful and sophisticated, like Venice, Genoa, and Pisa, led the development in technology. They were benefiting from the exchanges between the Orient, they are facing Middle East and trading with China, India, and other places, and Europe. And so they were at the crossroads. So these countries did a lot of stuff in developing of technology, in particular the first European rockets. So the first time in European warfare, rockets were used in 1379. So this is the way how rockets were fired in those days. So this is the rocket device with the guiding stick for stability. And as you can see, the aiming, as it is being done here, is not really very safe. If this rocket would start firing and send flame in the direction of this fella, he's in trouble. So it's a question, aim it and then step aside before you ignite this. So we already mentioned India a few times. So in India there was a truly major development of rocketry. And it is not even clear whether the first rockets were developed by Chinese or maybe by Indians. As we said, the records, Chinese records, are much older. So, for example, there was a famous battle of Delhi in 1399, where the invading troops of Tamerlane, or Timur the Great, fought, and they defeated the Indian army, and then they captured Delhi. So Indians deployed against the invading troops 125 elephants, as famous Timur wrote in his memoirs. So, and these elephants was covered with armor, and on top of the elephants there were hudas. Hudas is a basket sitting on top of elephant where the people could ride. And the soldiers from these hudas were hurling grenades, fireworks, and rockets. Again, very large scale. So, and the rocketry in India expanded, and it was not a few rockets being built. It was done on the massive scale. In particular, the famous became a state in the center of Indian subcontinent known as Mysore. And Hyder Ali, the ruler of Mysore, in the 18th century, he developed a special rocketeer force in his army, 5,000 men strong. And his son, Tipu Sultan, advanced this rocket force even further. But there was also a major technological advancement in India. Chinese rockets were made, it was basically a case with a gunpowder burning inside. So this case in China was made out of multiple layers of paper glued together. The Indians went one step further. They replaced these paper cases with the soft iron metal cases. So now they can contain a much higher pressure than Chinese rockets. And because of that, Indian rockets became much, much bigger and could fly much larger distances. So the Indian rockets could fly up to 1.5 miles range, and the mass increased to 12 pounds, so say 6 kilos. And but rockets still remain highly inaccurate and erratic. And again, to make a point that this was not just a few devices built. So when the British Empire finally defeated this state of Mysore and established its control of the Indian subcontinent in the famous battles of Seringapatam in the late 1700s, they captured 10,000 of Indian rockets. Again, it's not just a few rockets just fired by a few soldiers. It was a massive scale operation. So the Brits in India were alarmed by what they saw with this technology of rocketry. And by that time, tensions in Europe were rising, particularly between Britain and Napoleonic France. So, and one of the British inventors set up, with the help of the government, to develop rocket systems for future wars. His name was William Congreve, and he developed, one would say, the first rocket system in the world. In a second, you'll see why I'm not calling it a system. So it's a very sophisticated rockets. It was in the early 800s. The first time they were used against the French port of Boulogne, and then 1 year later, in 1807, the British Navy burned down Copenhagen, capital of Denmark, to the ground. So the rockets became known as the Congreves after the inventor. And this is what I meant by saying that this was a family. Well, first of all, the rocket just consisted of a warhead, and there was a gunpowder grain. That's a propellant that you have inside the rocket is called the grain, solid propellant. And so there was this chamber with the grain, and there was a guiding stick to help stability in flight. So the Congreve developed a family of rockets of various sizes with interchangeable parts. Again, it was done on the modern scale. So, and these rockets were very effective. They ranged from a very small, a few pounds, to as big as 300 pounds, and they flew up to a couple miles. So it was the big devices. and they were very widely used. So as you see in the beginning, the guiding stick was attached on the side of the rocket. This was not very convenient. And then there was an invention to make a centrally mounted guiding stick. So the base plate that closed the rocket where the burning occurred, instead of having one central hole, now the central hole was replaced by a few holes on the periphery. And the central hole was basically with a thread to screw in a guiding stick. So as a result, you have now a guiding stick centrally mounted, which immediately made possible to shoot these rockets from tubes, which improved dramatically accuracy, rather than from a trough with the side mounted stick. So the rockets became widely used on the land and on sea. So you see this is the launches on the land are shown here. And on sea, in the naval battles, they were very effective against sails of the ships at that time. And also, rockets do not have recoil. If you put a cannon on a boat and fire this cannon, so the projectile leaves, there is a recoil that will turn your boat over. So cannons can be carried on a small boat. Rockets don't have recoil. They accelerate themselves as they fly, and this propellant burns there. There's no recoil on the stand from which they were launched. This immediately enabled placing rockets on the small boats that could go into the shallow waters. It just changed to a significant degree warfare in the 19th century. A similar thing happened when the first airplanes were used for military purposes during World War I. So people could put a machine gun, but the planes were flimsy, and when the machine gun was fired from an airplane, there was a tremendous vibrations. People couldn't put a small cannon on the airplane because the recoil from a cannon would have destroyed the airplane. However, rockets could be put there because they don't provide recoil on the device from which they are launched. So the first rockets were used on the planes in 1916. Again, it's during World War I. And the rockets came to America, the War of 1812, between the United States and Great Britain. So the British very widely used rockets, burned a number of the American coastal cities, in New England in particular, in Chesapeake Bay also. And rockets were used on land by the British Army. And the famous case was in August 24, 1814, when the British troops were marching towards Washington, D.C. There was a Battle of Bladensburg, and Maryland militia were lined up in an exposed position. The Brits fired in a very effective way Congreve Rockets. The couple regiments fled because of that, and late in the day the British Army marched to Washington, D.C. and burned the President's house, the bridge across Potomac, the Congress. So this was the occupation of Washington, D.C. by the Brits, so rockets played a major role there. And of course, another most famous case happened a little bit later in 1814, in the middle of September, when the British Navy bombarded Baltimore, and Fort McHenry responded. So the British naval ships focused on Fort McHenry using mortars and rockets. And Francis Scott Key observed this bombardment, and he wrote his famous poem or verse that became the American national anthem, and Rockets' Red Glare. So these are the Congreve Rockets launched from the British warships. It was a special rocket ship, Erebus, built by William Congreve, actually personally, so designed and built under his oversight. These were Congreve Rockets in the American national anthem. So in the United States, this lesson of rocketry was learned a little bit, and after the War of 1812, the Army started to experiment with rockets, but on a small scale. The situation actually changed when a new war broke out with Mexico in 1846. Also, by that time, there was a major invention occurred. So this guiding stick on a rocket was very inconvenient for transporting and the maintenance and firing such rockets. So there was a British inventor, his name was Hale, William Hale, who came up with the idea, so just throw away this stick, and in these several holes, or nozzles as we would say now, on the periphery, instead of letting gases to go along the axis of the projectile, let's just tilt them a little bit, and in addition to thrust to accelerate the rocket, these exiting gas started to spin up the projectile, and this improved stability, and this immediately resulted that you don't need a guiding stick. So William Hale could not convince the bureaucracy in Great Britain to adopt it. So he came to the United States, and the war with Mexico is coming, so the United States Navy and the Army just bought his invention and developed these rockets. And actually the first missile unit in the United States Army was formed and was shipped with Expeditionary Corps that went to Mexico. So in the rockets were the first American rockets, the Hales were built in Washington, D.C., Washington Arsenal. This is basically in the downtown right now in the city of Washington. So this first unit, howitzer and rocket battery, was formed in 1946, and the first American rockets were fired during the siege of Veracruz. Actually, the Mexicans were first firing a day earlier at the American troops, their Congreves, Mexican Congreves. So there was an exchange of rocket fire. So it's a rocket that became an important part of warfare. The experience with rockets was not very positive, and primarily because they were very bad in storage. So you produce them, and then this gunpowder sitting inside the rocket cracks with time. It could absorb moisture. Some of them may explode prematurely, and when then you take a rocket from a storage and fire it again, it may malfunction. So the reliability was lousy. So this military brass was not very much excited of using rockets, but they were used. And as a matter of fact, during the Civil War in the United States, very few rockets were used at all. It was around 1860s, early 1860s. So this technology of Congreve rockets proliferated throughout the world. So it was the second wave of missile proliferation in the 19th century. So the large red dots showing countries with the major rocket establishments like in France, Switzerland, Sweden, the Russian Empire, Great Britain, United States also, small blue dots showing countries with the minor or smaller rocket establishments. So Great Britain and the Russian Empire used rockets until the end of the 19th century very widely in the colonial wars that they conducted across the globe. And rockets were very convenient in the poorly developed territory without roads in the mountains, because to pull an artillery cannon, you need a real road. You need to have bullocks or horses just to carry that, to pull it. And the rockets can be carried by soldiers on their backs simply. So with the poor terrain, rugged terrain, rockets provided some advantage. So it's interesting that the first country after Great Britain that really used rockets in the warfare was Chile, out of all countries. Again, it was 1819, only several years after the Napoleonic Wars and the War of 1812. Chile was a young republic that just kicked out Spaniards, the colonial power, and they built a navy, and in 1819 they attacked the Spanish war fleet in Peru, in Callao. It's the city on the coast of Peru. It didn't work very well, so the Chileans built like 1,000 rockets, but there was a little bit corruption in those days. We're not in a political science class, so we're not talking about current days. So you need a nice guiding sticks. So apparently there were crooked contractors provided crooked sticks. So they were not very straight. And also Chileans tried to save money, and they used prisoners of war, Spaniards, to build their rockets. And the Spaniards were apparently very big patriots, so instead of putting inside the rocket cases gunpowder, whenever they could, they put also manure, dust, sand. So out of these 1,000 rockets, only 10% functioned, 90% malfunctioned. But it was, again, interesting that a small country, just young country, only 1.5 years old, just tried to develop a major rocket force. Technology was advancing throughout the 19th century. So many things were improved. At first was centrally mounted stick, and then the spin stabilization was tried, and the fins were tried for stabilization. A very important development was the hydrostatic press, to press the gunpowder into rocket cases, because before people used basically wooden hammers to do that, or monkeys. A monkey was a piece of wood that you release and it dropped down to hit something. And if you drop it from a fixed height, you will hit it with the same force, right? So by dropping these wooden bricks, you can provide the same force for pressing gunpowder in the rockets. Production of rockets was extremely dangerous because using these either wooden mallets, hammers, or monkeys resulted in a lot of gunpowder dust went into the air. And this was a highly combustible mixture. There was explosions, people were killed in the factories. So the hydrostatic press improved dramatically safety and the quality of the rockets. And again, William Hale, the same William Hale of the Hale Rockets, was behind that. And just to mention another remarkable achievement, in big secret, the Russian Empire built a submarine. It was 1834, and the submarine could carry a crew of 10 men, and they could fire from the submerged position a few missiles that were mounted on the side. So it's a lot of technological stuff was done in the even in the 19th century. So particularly for our engineering students, it's a remarkable lesson just not to be too arrogant, just look back, because sometimes you can learn very interesting things. And without computers, people had to think much more than they do now, than rather running computer codes. So a lot of things can be learned from what was done in the past. In spite of all these advancements in rocketry, they were finished off by the end of the 19th century, no interest. And the reason is the rocketry was driven by military, and the military lost interest because of the tremendous advancements in artillery. So what happened in the middle of the 19th century in artillery through three things. First, the barrels were rifled, so now projectiles were spun as they leaving the barrel, so the stability of flight and accuracy of shooting improved dramatically. Breech loading, rather than loading through the muzzle of the cannons, improved the rate of firing dramatically. And also the Bessemer steel process produced much stronger steel. You can increase pressure in the inside cannons, and that means you can increase the size and weight of the projectiles and the distance that they were flying. So this just really finished off rocketry, basically. In addition, sails disappeared in the navies because now it was a steam-powered ships, and they put even some armor on the side, so the rockets were completely useless against them. However, rockets remained in the entertainment industry, like fireworks, and rocket-powered harpoons were used in hunting whales. It's very widely. And also for saving people. So if somebody was drowning half a mile from a shore, the rockets were shot towards this person with the rope attached. Hopefully you don't hit the person, but it's almost impossible to hit the person. From a half a mile, accuracy was lousy, and this was the way to transport a device for the person finally grab this rope and it would be pulled back. So when the shipwrecks occurred in the coastal waters, it was used in many countries. So as military lost interest, the writers picked up, and to keep the imagination of people and fascination with rocketry and also with space flight. Now, we have to mention that space travel was present in literature for many centuries by the 19th century, but there was an explosion of science fiction writings there, and nobody did more to advance space and rocketry in science fiction than the French Jules Verne. And in particular, his classic novel From the Earth to the Moon, De la Terre à la Lune, became really the turning point in the science fiction literature, and what was read by millions and millions of people across the world. They were translated in all languages, possible languages. And actually the writings of Jules Verne motivated the next generation of scientists and engineers that made spaceflight reality. Practically all who is who in rocketry and the spaceflight in the 20th century, Tsiolkovsky, Goddard, Everett, von Braun, Glushko, Korolev, all of them as kids read Jules Verne's novels. So in the literature, space or space travel never had a practical purpose. So mostly writers were sending their characters to space either because they argued among friends and then bet, well, I can do it, or you cannot, or try to escape more mundane causes. They try to escape deaths or wives, the marriage problems, all these things. Until 1870. In 1870, a most inventive writer, Everett Hale, he was an American, wrote a story, The Brick Moon. Hale was a writer, he was a reverend, he actually became a top clergy person of the United States Senate in the end of his life. So he lived in New England, and New England heavily dependent on fishery. A lot of people were just going and to fish, and weather, storms, poor navigation, and many boats or ships were wrecked and lost. Human lives were lost. So Edward Everett Hale, in his novel The Brick Moon, he said, well, if we have our moon in the sky, observing it, we can establish geographical latitude. If we launch an artificial moon that goes not along the equator approximately, but in the polar orbit over the poles around the Earth, then by observing it, we should be able to establish longitude. So this should help in navigation and will save lives. And in his novel, a bunch of friends just decided to build such an artificial moon. They built it out of the bricks, so it's the brick moon. And then by mishap, this unfinished brick moon was hurled into orbit by a huge water-powered wheel that they also built, and some people got trapped on this brick moon and they're flying there. So the first space station, people from the Earth was throwing them parcels with the food, and how would you communicate with them? It was a 19th century, radio didn't exist. So, and there was a very inventive communication system. So the people on this brick moon, they were lining up in a row, and some people were jumping up and others were standing. And the people from the ground was looking at them at the telescopes and binoculars. So those who were jumping up meant dashes, and those standing dots of the Morse code. So this was how they just communicated without even the radio. So it's again, this was the first book ever that in science fiction that brought space from the practical application to do something useful, not just for something for fun. So after this science fiction era, the first practical steps were done. So there are few visionaries appeared in the world. So 4 people played the most important role, and they were coming from the different countries, different lands, very different stories, and their contributions were very different. So one was Konstantin Tsiolkovsky. He was a Russian. He never built anything, but his visionary writings inspired the next generation of Soviet engineers that built Sputnik and sent the first man into space, Gagarin. Then there was the French, Robert Esnault-Peltry. Robert Esnault-Peltry was also an aviation pioneer. He had a aviation license, pilot license number 4 in France, or number 3. He was the guy who invented the joystick control the airplane and many other things. So there was some lawsuits and patents with some other people like Curtis in the United States about this. But again, he was one of the top inventors in the aeronautics. And he was a professional engineer in contrast to Tsiolkovsky. So Esnault-Peltry did probably more than anybody else to bring space and rocketry into the mainstream of science and engineering. In those days, if somebody will be talking, well, let's build a rocket and fly to the moon, this person must be insane and should be put in the special institution, because normal people wouldn't think about this. So Esnault-Peltry brought science and engineering into that just to legitimize the area. And because of his fame as an aviation pioneer, people took what he said very seriously. And he also was the one who introduced the word astronautics into the language of science and engineering. Then in the United States, Robert Goddard, he had a PhD in physics. So he was a real scientist, and he did a lot of development in rocket propulsion. A lot of theoretical, experimental work, and he demonstrated the first liquid propellant engine ever. And then there was the Hermann Oberth. It's very hard to tell what is his origin, because he was of a German extraction who lived in Romania on the territory that was controlled by Austro-Hungarian Empire. It was before World War I, and then all these countries collapsed. But he was culturally German, and in 1940 he actually got German citizenship. So he did a very influential. He wrote very influential treatises on introduced a lot of ideas in the rocketry and the propulsion. So these are 4 people, like 4 great pioneers. Now, a few words about Robert Goddard. So, as we said, he was the first who first ever flew the liquid propulsion engine. It's the most powerful rocket engines today. So he did it in March of 1926. So this was the beginning of the important era. Now, with Goddard, there's a very interesting story that he was maligned by the mainstream media in those days. Actually, he was doing rocket work since 1910, roughly. He was a professor of physics in Worcester in Massachusetts. And in 1919 and 1920, he published the reports on his work. And this was just very boring, typical engineering reports that people outside of engineering cannot enjoy reading. You know, you do some tests, how you organize the propellant, how you measure thrust. So it's a real hardcore engineering. However, in his report, he added a small theoretical chapter asking, so if I want to send a rocket 1 mile high, how much velocity I should impart to the rocket, or delta V, as we will say today. So he calculated. So then he asked the question, so how much velocity or delta V do I need to send a rocket to 10 miles? He calculated. And then he says, but how much velocity do I need to send a rocket to the moon? And here, Hale broke loose. The New York Times, on its editorial page, savaged him. That he is basically a charlatan, that he is a fraud, that so the direct quote is here. So the Professor Goddard, with his chair in quotation marks in the Clark College, doesn't know the relation of action and reaction if he thinks that the rocket could work in vacuum. So they really viciously attacked. He was hurt by that, and after that he basically stopped communicating with his colleagues. And in the late 1920s, he moved to New Mexico, to Roswell, and where he established a rocket lab and built with a few assistants, he built a series of rocket vehicles. They went up as almost like 10,000 feet, and he had more than 200 patents there. But he did not communicate with the colleagues. So American rocketeers that independently started to build up this field in the early 1930s tried to communicate with him, but he really refused to collaborate with anybody after that episode in 1920. So Theodore von Karman, major aerodynamicist, famous aerodynamicist here in the United States, called Goddard a dried branch on the tree of American rocketry, because American rocketeers had to reinvent almost everything that Goddard did. But this is also a lesson that if we do something in our professional lives and somebody doesn't like it, you should keep doing that, because again, there is a lot of ignorance and maliciousness in media, as in this case. And the New York Times sort of apologized in 1969. Yeah, well, a rocket can work in vacuum. Actually, a rocket is the only propulsion system that can work in vacuum, because it does not need a medium to push against it. So these were preliminaries, and the first modern rocket was built in Germany in the years leading to the World War II. So development of long-range liquid propellant rockets started by German Army in 1930, and this major effort was led by Walter Dornberger and Werner von Braun. Now, rockets and big missiles in general are the pieces of very sophisticated technology. And the individual inventors, even if you are very bright and capable, cannot really do it. They required a modern industrial state. They needed a number of scientists, engineers, technicians, different technologies, because again, it's a very complex technology. So the Germans put such a team together. The Soviet Union also put, even earlier than Germans, such a team together, but then internal purges in the Soviet Union wiped out this effort, or delayed it maybe for 10, 15 years. But the Germans continued, and they built a missile known as A4, and which is popularly known as V2. It's the German propaganda ministry during the war called it Vergeltung, vengeance, 2. It was a missile almost 13,000 kilograms in weight. It was 14 meters or 46 foot tall. It had a wonderful, really technological marvel rocket engine that was built up. And for those of you who would continue in the aerospace-related fields, the specific impulse was 210 seconds, which is a very, very serious achievement. And again, it's a technical term. If you're outside, just don't pay much attention to that. Just simply, it was a really, truly technological marvel. So it's not only that. Under the wartime conditions, the Germans succeeded to build almost 6,000 of such highly complex devices, highly complex missiles, and about 3,000 were fired operationally, mostly against London, Antwerp in Belgium, and a few other places in Europe. So it's, again, it was a truly technological advancement, and a lot of technologies developed there and demonstrated. They were just picked up and by the countries after the World War II. In the United States, the effort was much smaller than in Germany. Mostly smaller rockets were built for purposes, for example, to help heavy bombers to take off from short runways. They were known, these devices were known as JATOs, jet-assisted takeoffs. So solid rockets were mostly built, they sort of reminded you of the early Congreve type rockets, but were they built with the much better propellants, by much better technology, and they were widely used for bombardment of the areas where before the troops landed there. So in some World War II documentaries, you can see, especially in the Pacific, that the salvos of such rockets just covered the landing area before the Marines or the soldiers waded ashore. So another things what happened. So first of all, the United States Air Force was spearheading this development, in particular General Hap Arnold, but also in a very typical American way. This is in contrast to Europe or China. Immediately as the rocket age or applications of rockets started, the first private companies were formed to develop rocket technology and provide rocket-based devices. So one of them was known as the reaction motors, and another aerojet engineering that's still in existence, and they still exist since those days. Since 1942, when this company was formed. Today it's merged with Rocketdyne. It's called Aerojet Rocketdyne. So it's one of the biggest rocket companies building rocket engines in the United States. Still continues. Again, it's a very typical American, for the private industry to take part of the development. So very often people talk about this, when in the 1930s V2 was developed, being developed, why didn't people put a satellite in the orbit? A lot of technologies were needed. For example, communications, you want to talk to a satellite. A radio was known since early 1900s, but for example, telemetry or data transmission were first demonstrated only on an experimental basis in 1932. So many technologies were not there. How do you provide power to a satellite? If you have a mirror and a focus solar light, and then you have some kind of a generator, it's a very complex device. Solar cells were demonstrated only in 1953. So it's after World War II. There was also need for maneuvering of satellites and attitude control, or orientation control. So these kind of systems were developed in the early 1960s only. Now, attitude control and guidance of the aircraft, of space vehicles, this technology of guidance and navigation actually came out of the World War II, because the long-range bomber aviation just did a lot of development to support their mission. And in addition, you need a very expensive, very extensive ground facilities to test these huge rockets. So the Cape Canaveral was activated only in 1949, and in the Soviet Union a similar place for the similar purposes was construction started only in 1955, which would become Baikonur. So as the technology just proceeds, we have the International Geophysical Year announced, and it was a worldwide attempt by many countries to have a simultaneous observations of the Earth's environment, atmosphere, ionosphere, and everything like that. And you need it done to be in many countries because you want to see the global view of what's happening on Earth. Both the United States and the Soviet Union declared, well, during these International Geophysical Years, that lasted actually 18 months, from July 57 to December 58, so both the United States and the Soviet Union declared that they will launch scientific satellites, and both did. In the meantime, both countries that led the world, Soviet Union and the United States, were developing better and bigger and more powerful ballistic missiles. So the Soviet Union was the first to launch a satellite. So the satellite was launched by modified intercontinental ballistic missile, R-7. And again, this was development going since 1950 in the Soviet Union. And finally, as we said, on the August 29, just in 4 days, we will have the 60th anniversary. The Soviets demonstrated the first ICBM using this missile. And after that, on October 4, the Soviet Union launched the first satellite, Sputnik. Now, the two people, if we need to know the key names that were behind this, one is Sergei Korolev on the right, shown on the right here. So he's the man behind who put the first test rocket, who built the first satellite, and who would launch the first cosmonaut into orbit, Yuri Gagarin, and a lot of other things he did. Another person is Valentin Glushko, who was the man behind development of the powerful rocket engines that propelled Korolev's missiles into space. So two of them played the most important role. So, and we have, let me stop my, so we have the Sputnik launched into space. So this is this beep, 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 famous beep, beep, beep that was produced by Sputnik. One interesting story accompanying that, telling you how things are developing. In the United States, when Sputnik went up, there were the two young engineers, William Gaillard and George Waffenbach. They were working at the Applied Physics Laboratories between Baltimore and Washington, D.C., right in the middle. So they were young guys, just out of school, and they were also ham operators. But they had a very nice, smart boss. And their boss asked them, hey guys, you just listening to this Sputnik, everybody is excited. Can you analyze the frequency of the signals that are coming there? And from the Doppler shift, could you reconstruct the trajectory of the satellite? A Doppler shift is a change of the appeared frequency of the signal if the source moves with some velocity, or if you who receives the signal also moves with some velocity. So these two young guys said, oh, we don't know, and they busted their tails for a couple of weeks, and they succeeded. Just observing when the Sputnik was passing by, sending these beep, 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 they were just watching how the frequency is changing from this satellite appears over horizon, flies overhead, and just comes to another horizon. They reconstructed the trajectory of the satellite. Well, their boss was a very smart man, because in a couple of months after that, this Applied Physics Laboratory had a major contract from the United States Navy for the first space-based navigational system. Think about this. If from a known position on the ground, by getting signals from a satellite, you can reconstruct the orbit of the satellite, then if you have a satellite that is in a known orbit, then by receiving signals from a satellite, you should be able to determine your position on the ground. For the Navy, it was an absolutely urgent task, because the submarines with the ballistic missiles coming at that time online, And you cannot hit a target on the ground with accuracy better than you know your position from where you're firing. And if you're at a submarine, you cannot just get on the surface and spend 3 hours just looking at the stars and determining where you are. You will be sunk by that time. So the satellite system just was very important. So the first satellite system was known as a transit that emerged from that. And this system improved navigation and improved the knowledge of the maps. For example, Australia turned out to be about 1 mile away on the maps from where it in reality was. And the next stage of these navigational systems is GPS of today, Global Positioning System. It's just the expansion. So the Soviets launched a satellite. What was happening in the United States? The program Vanguard was activated. President Eisenhower started a program to build a satellite and the space launcher known as the Vanguard. Now, in addition, the United States Army, it's where von Braun worked, wanted to launch a satellite, and the Air Force that was developing Atlas, CBM also wanted to launch a satellite. But Eisenhower told them no. He wanted a pure civilian missile, non-weapon, to be developed to put a very small scientific satellite. And the reason was the following. Eisenhower was a very frugal man. He thought that the United States should only spend on the military as much as needed for survival, and not to match what the Soviet Union or the People's Republic of China was deploying thousands of divisions and aircraft and missiles. But you don't know what they have because they are closed societies. It's in the United States. With all the leaks in the newspapers and congressional hearings, you can just read newspapers and you can reconstruct a lot of secret stuff is being done. So the only thing for those closed societies, totalitarian communist countries, if you could put in overhead reconnaissance systems, reconnaissance satellites. However, there were no satellites at that time, and there was a major policy question. Can you overflight other countries by a space vehicle? By an airplane, you cannot. It's violation of airspace. You have to get the permission. But if it's a satellite, can you do it or not? Nobody knew the answer. So the Eisenhower said, let's just first build a simple scientific satellite. And when it demonstrates, which is now known as the freedom of space, that you can fly in any orbit anywhere you want, you don't have to carry whether the country below is happy about this or not. So let's just put a simple scientific satellite, and when everybody accepts this, then we'll start building reconnaissance satellites. So therefore, he said, no military participation. It's not a ballistic missile that will be used for the first satellite. It will be a new missile, Vanguard. And this is one of the reasons why the United States was not the first to launch the first artificial satellite. So the American program proceeded. So in the sequence of the events was the following. In 1956, there was a famous test by the United States Army, it's von Braun and his boss, General Meadows. They could have placed a satellite in September of 1956, but Washington specifically told them, when you shoot this missile, make sure you do not end up in orbit. Then, in October 57, the Soviet Union launches Sputnik 1, and then after that, Sputnik 2 with a dog Laika on board who died just after like 20 hours or 10 hours. It was because of the thermal control problems. So what was interesting, no countries objected to the flying Soviet satellites. So the Soviet Union demonstrated the principle of freedom of space. So now you can launch any satellite doing anything you want in space. Because of the Soviet success caused tremendous uproar in the United States. Congress jumped on the executive branch, and the media was just blaming everybody for the failure and the Soviets had. So Washington administration in Washington allowed United States Army von Braun team also to try to launch a satellite. So now the two teams in the United States would be competing to launch a satellite. And actually, program Vanguard in December of '57 had a major mishap during their launch. So finally, the American American program succeeded. So on January 31, let's try my pointer again. So in January 31, the Army team, von Braun team, launched the Explorer 1 satellite. And this is this iconic photo with the von Braun on the right, Pickering, director of Jet Propulsion Laboratory, on the left, and James Van Allen of the Van Allen radiation belts in the middle. So this rocket was launched successfully. Then in March 1958, Vanguard was successfully launched, and finally in December 58, the Air Force launched the Atlas, the first communication satellite, radio communication satellite ever. It is important to say that the Vanguard program was very much maligned in the media, in particular that, well, it's because they did not perform the team. The United States lost the race to be the first in space. This is absolutely unfair. It's only, as they call now, the fake media type just could do this. Vanguard was a big success. The first rocket, the first satellite they put in orbit successfully only after 30 months after the decision to proceed. Today, if you start building a new space launch, it will take you 5, 6, 10 years before you will be able to do. So it was a tremendous success. But unfortunately, in the public mind, Vanguard is considered as a failure, which is, again, highly unfair, and a lot of technologies were developed on that. So now I just have a very short video about the Explorer program, courtesy of our friends at the Redstone Arsenal.
Redstone's success prompted the Army to expand the Arsenal's mission even more by creating the Army Ballistic Missile Agency, or ABMA, on February 1st, 1956, under the leadership of Major General John Bruce Medeiros. The Von Braun team was assigned to this new agency. Medeiros' real legacy was as the godfather of the American space program. This is the Goddard House, which served as a VIP quarters during General Medeiros' tenure. Right behind it once stood an officers' club where Mr. Neil McElroy, Secretary of Defense-elect, dined on October 4th, 1957, after an orientation tour of the arsenal. While at dinner, the news came that the Soviets had launched Sputnik 1, the first man-made object into orbit above the Earth. Legend has it that Dr. von Braun asked to be given the green light, and the Army could launch a satellite in 60 days. General Medeiros asked for a little longer, 90 days. About a month later, the Soviet Union announced the launching of a second satellite, Sputnik 2. These Soviet satellites shattered American dreams of scientific and technical superiority. Amid mounting public pressure to respond to this Soviet challenge and repeated problems with the Navy-managed satellite program known as Project Vanguard, the Army was given the go-ahead on November 8, 1957, to prepare a Jupiter C that would launch the first U.S. satellite.
Good morning, gentlemen. Be seated, please. I have a very important announcement for you. We've been assigned the mission of launching a scientific Earth satellite. And we will use the Jupiter C configuration as a carrier that we developed along with the Jet Propulsion Laboratory. I promised the Secretary of the Army that we would be ready in 90 days or less. Let's go, Werner.
Just 84 days after receiving the mission, the Army team at Redstone launched Explorer 1 on January 31st, 1958. This team had faced and met the challenge that not only restored U.S. prestige, but also served as the impetus for the extraordinary growth and tradition of excellence that has become a hallmark of both the Redstone and Huntsville communities.
Hello, Len. You can send this off to the Secretary. That our satellite is definitely on orbit. Now get that off, and then I'll give you the figures in a few minutes. Okay, boy.
The National Academy of Sciences and the National Science Foundation announced that as part of the U.S. International Geophysical Year program, a scientific Earth satellite was placed in orbit at 5 seconds after 10:55 p.m. by means of a Jupiter C rocket vehicle launched by the Army at Cape Canaveral, Florida. A similar statement is being issued by the President. I should like to add my personal congratulations to the Army Ballistics Missiles Agency and to Dr. Von Braun and Dr. Pickering and their colleagues for a job well done.
As news stories of the Explorer 1's launch began to surface, thousands of people gathered on the courthouse square in Huntsville. Sirens wailed, horns blasted, and the sky filled with store-bought rockets and fireworks celebrating this country's first step toward the conquest of space. These celebrations were echoed across the nation. Many soldiers and civilians who today come to work for the Army at Redstone Arsenal are amazed when they learn of the significant role that the Army played in paving the way for the U.S. space program. From these roots grew a spirit of achievement, a legacy that has continued even after the Army at Redstone lost its space mission. Never at a loss for words, Medeiros was asked to speak to the Huntsville Chamber of Commerce on January 31st, 1978, to help commemorate the 20th anniversary of the Explorer 1 launch. By then a priest, Medeiros noted, "I do choose to remind the historians of Huntsville that the Army led the city from cotton and watercress to become the space capital of the United States."
So if we look at the first satellites, they're shown to scale here. So it's a Vanguard on the left, Sputnik on the right, and Explorer at the bottom. So one of the questions comes, was there a technological gap between the Soviet Union and the United States? And the answer is really negative. It's simply the Soviet Union put a focus to achieve it as quickly as possible, in contrast to the U.S., where President Eisenhower tried to first demonstrate by non-military missiles just the launch of a satellite for the goal of having a reconnaissance system in the future. And by December of 1958, the U.S. deployed 3 satellites built by 3 completely different teams, completely different subcontractors in the industry. So there was no technological gap really. The Soviet space launcher was much bigger than American, so this is again shown to scale. This is the Soviet launcher, or the first Soviet ICBM R-7, and the Atlas Jupiter that launched Explorer 1 and the Vanguard. So R-7 was much bigger, and the reason that it was much bigger than Atlas, it became the first US ICBM here, was that these ICBMs were built to deliver nuclear warheads half a world away. And the American nuclear technology were more advanced than Soviet by a few years, so the American warheads were smaller and lighter. So for the Soviet Union to deliver a nuclear warhead, they needed much bigger rockets. So then this rocket was built R-7 that became, in its civilian variant, is known as the Soyuz space launcher that is still being used by the Russian Federation to launch satellites. So other nations followed to putting the satellites on their own rocket launchers. So the Soviet Union and the United States were followed by France in 1965, then Japan, then the People's Republic of China, and then United Kingdom in 1971. After that, all European individual space programs by individual countries stopped, and they combined their efforts in the European Space Agency. And the European Space Agency now launched the European rocket Ariane into space in 1979. After that, India demonstrated a launch of its satellite. And actually, the satellite program in India was managed, or the first launcher was managed by the person who later would become the president of India, Dr. Kalam. So it's a very unusual for a rocket scientist to become a president. There's only another case, only one other case that it happened also. Then Israel in 1988, and then Iran in 2009, North Korea in 2012, and South Korea in 2013. Brazil had a vigorous program, but there was a major setback. There was a major explosion during the tests in 1999, and a number of engineers were killed at the launch site, so the Brazil sort of came the development slowed down dramatically after that, but they still plan to do it. It's a question of time when Brazil would also join this elite space club. So the first 1,000 years were very successful, was a spectacular success, and the next 1,000 years would be even more exciting. And nobody said that the road to Alpha Centauri, the closest star to us, would be easy, so through difficulties to the stars. So this is all for today. We will meet tomorrow in the morning. We'll be talking about what people do in space in the 21st century, various technologies, science endeavors, and many other things. So I will see you tomorrow. Please pick up some of these wonderful things if you haven't done so, and I'll see you tomorrow.